Thank you for coming and thank you those online. So today we have a talk and a demo by Moiz Penkar. And sorry if I don't pronounce your name correctly.
It's very bad.
Sorry. How do you pronounce your name?
That's fine.
Okay. On Actigaze technology. So Moiz is going to share with us his research and his findings on how Actigaze trackers can be used to clicking hyperlinks with your eyes. And he's going to share with us his usability findings and challenges. And after the talk, we're going to have a demo with the prototype he made.
Kia ora koutou katoa. Thank you very much, Kamiri and Ian. So these guys have worked very hard over the last week or so to organize this event, both in person and online. So just a shout out to them. Maybe we give them a big hand. Well done. Okay, so how many of you have used eye trackers before? Yeah. So can you quickly, both of you, tell me a little bit about what you were doing with it?
I was just trying a friend project. He was actually doing a master at the School of Architecture and Design.
Cool.
And basically the whole thing was about moving into a virtual space, and he was recording the data.
So it was used for interaction purposes, or was it just recording where the user is looking?
Yeah, recording where the user was looking in that virtual space.
Cool. Okay, so it was just for recording purposes.
Yeah, for the user study.
User study. So cool. All right. And user?
Yes, I had an experience probably a couple of weeks ago with an online something that I got drawn into. I can't remember the context now, but basically I had to train it. So there was a dot that moved around, and I had to keep looking at the dot.
All right. Awesome.
And to be honest, I got through that class, but I can't remember what happened after that. I think I was actually responding to questions and looking at things.
Right. So it was probably trying to calibrate for your eyes when it was asking you to look at different dots.
Yeah.
And then maybe it was also going to be recording your gaze.
Yes.
And it was similar to that usability study. Yeah.
I think so.
Cool. Anybody online has something to say if they've used eye trackers? We'll give them a minute, a few seconds. Is there anybody who's used eye trackers before?
No messages yet,
No?
but
Cool.
I can interrupt you.
All right, okay. So these were examples of using eye gaze tracking for usability studies, but the same technology can be used for, yeah.
We have someone here. You said they had.
And what were they doing? What was the use?
We have to wait for
Yeah.
them to reply. Usability research.
Usability research again. Okay, so 3 people who have used it for usability or user studies. So I guess tracking can be used for that, but it can also be used for other studies like market research. So market researchers try to figure out what sort of packaging is the most effective, what sort of messaging on the packaging is most effective for the products, what's the best place for placing products in the retail space. So Actigaze tracking is used there a lot. And then you can use Actigaze tracking for interactions as well. So you can use the information of where you're looking as an input mechanism for the device. So output for you and input for the device, right? So it is this Actigaze tracking for interaction, which we'll talk about in a little detail today. Any questions so far? Cool. People who are online also feel free to type in questions, and Kamiri or Ian will interrupt me from time to time. Actigaze tracking is considered a promising component of natural user interaction. Obviously, because it's so easy to use, you don't have to tell people how to use your eyes. It just works. It's natural, it's fast, it's one of the fastest pointing devices that we as humans can use compared to other options that are available. We can just look at something and that is the point. And it reflects our intentions, it reflects our attention, which is useful information for interaction design. And it's a potential solution to repetitive strain injuries. How many of you have some sort of strain injuries, overuse syndrome? Yeah, a few people. Yeah, so that's a common thing. We're not designed for typing and using mouse from the evolutionary perspective. But anyways, that's a separate story. And Actigaze tracking is becoming more accessible with time. And by accessible, I mean it's becoming cheaper, more affordable, and also more portable. So it's easier to now have eye gaze tracking in consumer devices. And Superman happens to benefit from some of the benefits that we talked about. So he has an edge over his opponents because he can just look at whoever he's fighting and zap them off. But there are challenges. So when we use eye gaze interaction, pointing is relatively straightforward, but when we start using gaze for performing actions, that's when we run into problems. How do we differentiate between an exploratory gaze and an intention gaze? That's the problem that Cyclops from X-Men suffers from, which is why he needs this extra device that he wears. And the other problem is that there is an inherent lack of accuracy and precision in the way our eyes work first, and then the way the equipment tries to record our gaze is also not very accurate. So these are the challenges that we have to deal with. This is a before picture. During the first few weeks of me starting my research, almost no white hair. And the phone that you see in the background, this phone is a standard, not a smartphone, but came with an FM radio, really good quality FM radio reception. You could listen to music without using your internet. It makes me feel sometimes that we've gone backwards. But the other important tip for people who are doing a PhD or wanting to do a PhD, is there anybody who is intending to do a PhD or in the middle of it? So just a helpful hint, if you know somebody, they can benefit from it. You see a research paper in the background of the desk. So always have at least one research paper that you are reading or you have to read, always there on the desk. Or when you are going to attend nature's call, you just pick it up and take it with you. That's how you read a lot of research papers. Okay? Otherwise, it's impossible to read all of them. And don't get a smartphone, because otherwise you leave the research paper and take your smartphone with you. All right. I won't go into too many details of what other people have worked on, because that might take too long, but just pointing out that the things that people had worked on, they had the same problems that eye gaze tracking has. So either the technique is too distracting, or it still suffers from that Midas touch problem, the inadvertent clicks that we talked about, and they would either be too tiring or unnatural to use. Some of them would be too slow. So each click would require 5 to 10 seconds. Another example where there was average selection time of 5 seconds. So because of these issues, eye gaze interaction is considered only feasible for people with limited accessibility, because the threshold for convenience is very low. So eye gaze interaction is then not considered feasible for everyday use by everybody. Another example, this is a commercially available product called IntelliGaze Desktop. Again, it suffered from the slowness and the distraction that comes up with the extra things that go on the user interface. So based on that, my research motivation was to see if eye gaze interaction can be made feasible for everybody. Because there was a strong reported preference for minimum deliberate eye movements, because we as humans don't control our eyes very consciously. It's almost like an automatic thing that we're doing. So if the instruction manual says that do this with your eyes, then it's something that we don't like to use over a long period. So this became sort of like a guiding principle for my research, that whatever I work on has to be really easy to use and very simple, almost requiring no training. And a technique that is convenient and fast, but is also accurate and precise and error resistant. So these are basically opposing requirements. As soon as you start making it too fast and convenient, you end up with more errors. If you try to make it too error resistant, then it becomes slow. So how do you find that balance between the two was a question that I was dealing with. And because our gaze in behavior depends a lot on the context or the task that we're performing, so I ended up narrowing down to the use case of clicking hyperlinks. So only focusing on how we can click hyperlinks using eye gaze interaction. Any questions so far? Cool. So this is the first equipment I started working on. These are the two cameras. You needed a desktop for this one to work because there was a specialized video card that did image processing from these two cameras and then returned the coordinates, both eyes. This one was the second one we got, a slightly newer product. Again, as you can see, more portable than the first one and could be connected to a laptop or a desktop via just a USB port. The old one also did not allow a lot of head movement, so you would almost hold your breath while using it, because as soon as you moved a little bit, it lost your eyes and it couldn't work. The newer one allowed you to move your head around and you could still use it. Just one of the first implementations of moving a box around the screen following your gaze and showing you your gaze coordinates. What you see on the left, the top left, was a game that my co-supervisor used for teaching one of his CONSCI courses. So he used to use this example to teach collision detection. So basically, how do you detect when a fireball has hit your spaceship? And you control the spaceship using arrow keys. And I sort of rewired it to work with the gaze tracker. So you just look at the direction you want your spaceship to go to, and the spaceship went that way. It was just a good experience to understand more about how eyes can be used as an interaction mechanism, apart from also being a fun thing to do. So the one on the right, the bottom right, is just a concept of drawing some confirm buttons on the side and having a visual link to the hyperlink that they would activate if you dwell on them. So dwell is the name we use for looking at a button for a certain time. Another concept we evaluated briefly, the link that you would be dwelling on would get loaded on the side, and you would dwell on the page that loaded on the right side, and this became the primary page, and the cycle then continued. Another prototype with confirm buttons on both sides, again using visual markers to link the buttons with the hyperlinks. So after doing these few prototypes and trying to understand what works and doesn't work, we started getting a few questions that we felt we didn't know the answers to. And those questions were about, what is the effect of different dwell times? So the time you use to indicate an action, what is the effect of using different times on accuracy? And the same question for the button sizes. How does the size of the button relate to the end usability of a confirmed button? And we couldn't find, we did find a few things from other researchers, but it didn't seem enough to be able to use for further prototype design for our study. So we decided to test these things out. And the second question we wanted to look at was the effect of moving the content of any clickable area outside of the area itself. So if you just look at the two screens here, the words are inside the clickable areas on the left, but on the right, we've got the content outside of the clickable areas. So the users would look at these blue circles to indicate which choice they would work on. Is there a question or
No?
Okay. The results seem to indicate that separating the content completely took care of the Midas touch problem. Nobody would look at the wrong circle. So basically, we would completely get rid of that inadvertent clicks problem.
No,
Yep.
a question. Mark is asking, what were the dwell times you experimented with? Shortest dwell time and longest?
From memory, I think we had 250, 500, and 750, three dwell times. Yeah. Milliseconds, yes. So that was a good finding. That was very positive for us to know that we can basically completely take care of that one problem. And the combination of larger buttons and shorter dwell times seemed to work the best. And in the process, we also found what we call the gaze hold problem. It seems that if you ask people to dwell at any point for too long, it's very difficult to do that. Even if you ask them to just continuously look at some point, they end up looking on the sides and on the borders and those kind of things. And that's just the way how we work, how our eyes work. So the dwell times need to be short, but the clickable area needs to be large enough. Based on the results, we went on back to the concept that we had worked on and then tried to come up with a few options, how we wanted to now work on a web browser. Research questions we framed for this was, in the context of a web browser, how do we apply those findings to increase, to deal with the lack of accuracy and unintended clicks, and in a way that is convenient and efficient as well. And you're placing the confirm buttons in the margin, which could potentially be distracting by itself. So having a new artifact appear on the side is something that can cause visual distraction. So that's something we wanted to understand a little more about. How distracting would it be for the users? So we created 4 click alternatives. The first one was called direct dwell. Anybody wants to quickly try to explain how this would work? Yeah.
Well, I'm going to guess that when it thinks you're focused on a particular hyperlink, it highlights that, and if you hold that position.
Exactly, yeah. So you basically are reading through the links, and any link that you hold your gaze on gets clicked, and that's the direct dwell click alternative. And just to indicate to the user which link is being warmed up for clicking, start showing a gray border which darkens with time. So that was the first one, called direct dwell. Second one was called the single confirm. Anybody wants to try to explain this one?
Same thing, basically.
Basically the same thing, but instead of just looking at the link to click it, looking at a link would activate a confirm button in the margin. And then in order to click, you would look at the confirm button, right? And just to provide a confirmation of what link this would be clicking, we added some starting text of on the link just next to the button, right? So this was called the single confirm. Third one was called the multiple confirm. Who wants to try to explain this one? Yeah.
All the hyperlinks and just dwell one to one.
Yeah, so because remember we talked about gaze suffering from lack of accuracy. So in this case, the user is looking somewhere at this point, and there are 3 links in that vicinity. So we basically draw confirm buttons for all those 3 links. And the text is for confirming which one is which, right? So that was the third click alternative, yeah?
So just a question of delay, because if you then gaze across
those,
would it pick up the other links, or was it a rough kind of
Yeah, so we built those steps in. Only if you stopped at link on the way, would these links get deactivated and new ones get activated? Yeah. So all those things had to be taken into account. I also ended up reading a lot about how reading works with eyes, the saccades and fixations, that the way eyes jump from words to words, sometimes skipping words, sometimes stopping in the middle of words. Fun stuff. And this was the 4th click alternative we worked on. Who wants to explain this one? Anybody online who wants to have a go? Let's give them a chance, and just to see if they can participate a little more.
Mark said, same as waging.
Same as multiple, he means, or?
The buttons are overlaid.
Yeah, so basically just another way of presenting the multiple confirm, but this time the buttons are not being drawn in the margin, but around the gaze circle, right? So in this case, the gaze is being reported somewhere on this area, and 3 buttons being drawn. And depending on which one you want to click on, you'll dwell on that confirm button to click that link.
If you didn't want to click on that link, you'd look in the opposite way. Like if you looked up but not to the right, would it think it was that top right option? So if you didn't want to click any of the links.
Yeah, right? So if you didn't look at any of these, and if you then started looking at other links, then these would disappear, and yeah.
Would other links immediately show up, or would it?
After that activation time. So there was the initial activation time, and after that activation time, you would have the buttons show up. Yeah.
So is it showing 3 buttons there because it cannot distinguish
Yeah,
confidently
exactly. Yeah,
which
yeah.
one you're
Which
looking
one? Which one you're looking at?
So if there was only one hyperlink
Then,
there,
yeah.
it would only show one button.
Yeah.
So it'd be like hypertext.
Yes. Yeah. Cool. So these are four-click alternatives that we designed, and then we conducted a usability study with the mouse as the control. Which one do you guys think worked the best out of these four? So what was the first one called? Direct dwell. Second one?
Single button.
Single confirm button. Very good. Third one? Multiple confirm. And the fourth one? Radial. Who thinks dwell worked the best? Hands up for direct dwell. 1, 2. 2 people for direct dwell. How many for single confirm as the best? None. How many for multiple confirm? 1, 2, 3, 4, 5. 5. How many for radial? 1, 2, 3, 4, 5. Okay, good. What's the online voting looking like?
So we have 2 for radial, 1 for multiple, and a 4 direct,
Yep.
and another 1 for multiple.
Cool. So as it turned out, the direct dwell and the radial were a complete failure. They just didn't work at all. Based on the results of the pilot study, we took these two out of the full experiment. So basically, we were down to using multiple confirm and the single confirm against the mouse. Out of those two, multiple confirm worked the best. It was the clear winner. And this was an interesting finding overall, that the confirm buttons appearing in the margin did not cause any unnecessary distraction. The users were already put in through like a 2-minute training so that they get familiar with how it works. And after those 2 minutes, because they were already expecting things to be changing in the margin, they didn't get distracted by the confirm buttons. This was another interesting thing we found, that the minimum time the gaze stops in a position is about 400 milliseconds, which basically means that even if you want to look at something and move away from it as soon as they can, even then they end up looking at it for about half a second. And that's an important thing to know if you're designing in user interfaces for gaze interaction. What was also interesting here was that although multiple confirm worked really well, it was still slow. The average times were like 7 to 8 seconds. So that's still above that 4 to 5 second threshold where the users start feeling that it's too slow. Anything that takes less than 4-ish seconds, the users are happy with the performance.
Yeah. I sort of discarded multiple because of the cognitive load. You've got to read the text, memorize the length name, and then go and find it on the list. So
yeah, so
I understand why it took so long to do it.
Yeah, yeah, and also because now you are presented with another choice that you have to take. So that is another cognitive step involved in the process, right? And which is sometimes causing at least 2 to 3 seconds delay. So yeah, exactly that. Yes. So although so that was the interesting outcome, that it solved the inadvertent click problem. It solved the inaccuracy problem as well, but it was not quite fast enough. So that was the finding from here.
What was the problem with the radial?
Okay, so the problem with the radial was that if you just visualize looking at different parts of the pages and the radial buttons being drawn around your gaze area, every time you got these buttons drawn in a new layout, depending on how the links were placed from your gaze point. Okay, so the fact that every time it was a new pattern that would show up was so distracting, and you would just like to see what is happening around, and your gaze would just get distracted by what is happening just in the periphery. Okay, which is how naturally we operate. So if we're looking at something and things happen if there's a fly that starts flying on the side, quickly our gaze just gets distracted by it. So that's what was happening, and sometimes that would cause a click.
But you didn't try a mix between the radial and the multiple choice, like having a line linking directly
So based on those initial studies that we did, in which something like this, you mean, right? So there are multiple buttons, but there is a line connecting to the buttons. Yeah. So based on this, we felt that these lines were aesthetically were reducing the quality of the interaction. So now you have these lines appearing and disappearing all the time. And sometimes if it was a high density link area, then you would have too many lines appearing and disappearing. So it could have worked, but we just did not want to pursue it further because we thought that, yeah, we're losing on the aesthetic side too much, and it would never be used by everyday user because it's just dirty. Too many lines. And if you imagine on the online world, an underline already has a connotation of having a link associated with the underlines. So that's a convention in HTML that a link would be underlined, or at least in these days it's changed, but that's how it used to be at least, and it's still used by many websites.
What kind of tasks did you ask of the users? Was it simply clicking a link, or was that to browse through a website and find pieces of information?
So these were all predefined and pre-chosen links, and we would train the users on those tasks before doing the measurement tasks. A series of clicks that they had to do. And basically, there were 2 navigation tasks. Both of them had 4 links that they had to click. Yeah. And again, full details of that available in the thesis, which is also right here outside today. So yeah, that is good discussion. Anything online?
Yeah, Q says, fascinating. Thank you so much for detailing why some options work better than others.
Awesome. Thank you so much.
And yeah, I'm saving a couple of questions for Ian.
So based on the results of that study, we then created another prototype using color as the connection between the links and the confirm buttons. Okay, and we created 2 variants of this. So this is basically multiple confirm again, but now each button has a color, and these buttons are always fixed in their position, as opposed to multiple confirm where buttons would appear and disappear. Now these colored buttons would always be there, and this is the dynamic coloring variant, in which if the user is looking somewhere here, these 4 links get activated by a color, and in order to click any of them, you can look at the button of that color. And that sort of partially took care of that cognitive load that was involved, or the choice step that was involved in disambiguating between links. So this was the dynamic coloring variant, and the second one was the static coloring. The only difference was that in static coloring, the links would, when the page loaded, the links would be colored right away. Whereas in the dynamic coloring, the color highlight would only appear once the gaze was detected in that area. Any questions on this? Yeah.
Colorblind?
Very good question. So in my study, I happened to have, just by coincidence, one participant who had one form of color blindness, because there are multiple, and he was still okay with the colors that we had chosen. But that doesn't mean that it will work for all colorblind cases. But colorblind doesn't mean that you cannot use colors at all. You just need to know which colors to use and which ones not to use. So that's one possible response. But the other is that you could also use patterns as the identifier.
Or if you know that you have an input,
Yeah.
that can specify colors depending on what
Yeah.
you see.
Yeah.
I guess it's a training thing, right? So
Yeah.
you look at colors, you work out which ones work.
You would, yeah. So yeah, good question.
So the other example you gave, which had all the links
Yeah.
highlighted. So you've got multiple links with the same color. So how do you, I can see
So there's
art, history.
so the same color is being used on multiple links.
Yes.
So now based on where you looked at before looking at the purple or each button, that's the one that got activated or clicked, right?
I have a question. He is asking, how is the static coloring different? Sorry, I missed that.
Okay, yeah, so the static coloring highlights each link as soon as the page loads, whereas the dynamic coloring only highlights the links when a gaze is detected in the vicinity. Does that answer the question?
So, yeah.
Thumbs up or thumbs down? Yeah, feel free to ask more question on that if that was not clear. So what do you guys think, which one worked better out of the static and dynamic coloring? Again, we use the mouse as the control.
You say dynamic.
Dynamic, okay.
Jason.
Okay, hands up for static. 1, 2, 3, 4. Cool. Hands up for, that was for static, right? Or dynamic?
Static.
Static. Yeah, dynamic. The rest, all of them. Okay, so.
Would it
Yeah.
depend on the person and how they're
Of course, it would depend on the person, but we're talking about aggregates now. So we had, I think, 24 participants for the study, and the results. So this is the usability scale score. How many of you have used this in your research? Yeah. So really popular tool, really useful, I feel. So the usability score, the SUS scores for the mouse dynamic. So the mouse was the clear winner. Dynamic came second. Static came last. But we also asked users to rank these three options from 1 to 3, 1 being the best, 3 being the worst. So static coloring, clearly very bad. 21 out of 24 people ranked it the worst. 2 people ranked it the second. There was 1 person who ranked it the best. So depends on the user. But overall, failure. 13 people considered mouse as the best. So mouse was expected to be the best, but we were really happy with this number here. 10 people said dynamic coloring was the best out of the 3. So that was that eureka moment. And if you look at the people who either ranked first or second, dynamic was ranked either first or second by more people than the mouse. So in a way, dynamic was something that people were really happy with. Any questions on this?
think of reasons why.
They were just delighted initially when they felt like they don't need to use an extra device, because you're already pointing at stuff when you're using a mouse or a trackpad, right? You're just doing the look. So people felt initially, they reported being excited. They said things like, how does it know what I'm thinking? So that was the question they would ask. How does it know what I'm thinking? Although we weren't looking at what they're thinking, but this is what they felt like, that it's able to read their minds. So they were really delighted by how easy it was to use, and it was really not difficult to understand how it worked. Did not require too much instructions. You just let people in front of the screen, and they just try a few things, and within a few seconds they know how it works.
That sounds like the dynamic one. Almost their response was almost unconscious.
Exactly.
They thought it was reading your mind.
Yeah. That's what they initially just automatically ended up saying. But yeah.
What was obviously the static got a very negative response.
Mm-hmm.
Was there any reasons given for such a negative response?
There were no reasons given, but what we tried to look at from the data that we were recording, the gaze data that we had recorded, we could see that the fact that in case of dynamic, there was a confirmation or an indication available to the user when a link is clickable. And that was missing in the static, or the way we had implemented the static coloring. So here what sometimes happened would be that the users because they were already trained on the task, they knew where the link Americas or Africa is going to appear. They would just go through it very quickly without waiting for it to be activated, right? And then they would look at the button, nothing would happen. So then they would come back and then try again, and then it would click. So that was not the best user experience for them.
Why do you think there's a discrepancy between the SUS score and the rankings? I have used the SUS score before, but
In terms of, so when you say discrepancy, what exactly do you mean?
well,
by that?
the mouse looks, it's not a huge one, but the mouse looks like a clear front runner there.
Yeah,
whereas in the next ranking is a lot more closer, right?
So they are basically measuring different things, I would say. So our ranking forces the user to choose one over the other, whereas that's not the objective of an SUS score. And the difference between the numbers in the SUS scores also don't mean much. It just gives you an indication. So let's say there was a little difference here and a big difference here. We shouldn't read too much in those things, because the way SUS ranking is designed, it's not meant to measure the ranks. It's just meant to measure the overall user experience that the user is experiencing.
What's considered a good or above average score?
Again, no, it all depends on the type of system you're measuring. What is useful is to do a SUS score of an existing system and then make a change, and then you do an SUS again and see what the differences are. Yeah, so it's the comparison that is more important than an absolute score. Yeah, but overall, higher the better. Excellent. So this is basically showing the click times of these three options: the mouse, the dynamic coloring, and the static coloring. Mouse was clearly able to do most of the clicks within the 2-second range. Dynamic coloring about 3 to 3.5 seconds, which is again a good performance. We were very happy with having the most clicks within 2.5 seconds. Static coloring was okay, but not as good. Again, we saw a lot of slower clicks in the static coloring, sometimes taking up to 11 and 12 seconds. Okay, so that is really bad user experience. So it was obvious that it is very bad, or we did a bad job at implementing the way we did it. The question then we asked ourselves was, the people who are using the mouse have already been using it for a very long time, so they are expert mouse users. But the eye gaze interaction was something new for them. They had a training for about a few minutes, but still they were doing it for the almost the first time during the studies. So the question we asked was, if we have more experienced users, can we make the performance of the dynamic coloring closer to the mouse or not? So we ended up doing like a very limited study with only 3 participants, clicking a lot of links again and again. And these are the results of that small study. And although we were not able to get rid of the long tail, still there were some links that took longer to take, and maybe that's just the way eyes work. But we were still able to get the majority of the clicks within the 1.5 to 2 second mark. So that was again a very positive result. And as a conclusion of everything, pretty much we felt like we call this technique Actigaze. We felt like it was something that is feasible. It generated excitement. It was an efficient solution to inadvertent clicks. People were not clicking by mistake anywhere. Inaccuracy was taken care of by this. Dynamic coloring turned out to be the faster of the other alternatives and was not considered distracting or tiring. The fact that there were colors popping up on the screen theoretically could be very distracting, but none of the users felt like that was a deal breaker or that would be distracting and they would not want that to happen. Frequent use increases the click performance even further, approaching that of the mouse, but really not beating the mouse. And the final conclusion was that gaze interaction has potential to be used as input method for all users. question, yeah?
Yeah, sorry, just one more question about the dynamic. Were the colours pre-assigned or were the colours assigned according to, you know, sort of like a heat map thing where the one that was the closest to where gaze was a particular colour and then they worked their way out?
So the colors were assigned in order of the link, of the appearance of the links, which means that the same link would always appear the same color on the same page. Unless there is another link that got added up before that, the link would always appear the same color. Yeah. So there was that was a learnability factor involved as well in this. Not just here, but also on the side. It seemed that people started remembering where the buttons were placed. So they would not be looking or searching, trying to find the colored buttons. They would just go directly to the right confirm button. So with that, we come to the after picture. Ready? Oh no, before that, just some limitations on the study. We were using predefined and known hyperlinks. So extending the findings to general use, a little bit of a stretch. There were some equipment limitations we were dealing with, especially the usability or the user experience factors. For example, the first equipment we were using that required you to just stay still for a long time, and that itself was bad user experience for many participants. So there were some equipment limitations which affected our results. Color can be a distracting element because in certain interactions, color means different things. So that is a limitation of the Actigaze. And we use mostly computer science or engineering students as study participants. So again, maybe extending the results to general population should be taken with a slight grain of salt. So now we come to the after picture. A little more white hair now this time. And the rest seems to be okay-ish. So I survived. All right, thank you very much. More questions or?
So you touched upon this a little bit, but Zaid wants you to elaborate a little bit. So Zaid says, I missed how the dynamic grouping works. How does the tool assign a color to those elements? Are colors unique or reused?
So the colors are reused. 7 or 8 colors that we were using. Do I have all of them? Yeah, there we see all of them. So these are 7 colors that we used, and these colors were being reused over in order. So if you see the 7 links here, each use different color, and then the next 7, and then the next 7. So it was the same process we used to assign the color. With the static coloring, we just showed those links highlighted right away, whereas with the dynamic coloring, we only highlighted the color when the gaze was detected in that area. Does that answer the question?
I think it does.
Yeah.
We have another one from Zaid. There's, by the way, a lot of good responses online, and everyone's really impressed with the research. I'll ask another question from Zaid. Who would be the audience for such products? As product designers, what can we do better to ensure our solution is more accessible for such tools? Are there government requirements to make sites, for example, eyesight accessible, and are there timelines to make that happen?
What is the last part of the question?
Are there government requirements to make sites, for example, have eyesight, make it accessible by eyesight? I guess is what he's saying. And are there timelines for that to happen? So that might be a bit of an open question.
Yeah, so accessibility is like a complete different subject. And if you notice, accessibility was not the main area of my research. I was actually doing the opposite of accessibility. So although gaze interaction is already considered feasible for accessibility purposes, and there's already a lot of products out there. So Stephen Hawking is the famous celebrity who used eye gaze interaction to communicate with people. Although that was not the main objective of my research, on the other hand, because I ended up reading so much, I can say that there is still scope for using eye gaze interaction for accessibility. It's still like an opportunity out there, having good accessible interfaces for so people can use everything. What was the other part of the government guidelines? Different governments have different ways of looking at it. I think I could be wrong, but I think Western Europe and the US are sort of like leading on that aspect. So yeah, I think maybe that person is online on the Zoom call now. Also, she was just telling me a few days ago that in the US you can sue a website if it's not accessible to you and if you're a limited accessibility user. And I think it was like a private chiropractor practice, and somebody who was wanting to, I don't know the full details, but I just heard the news that yeah, the chiropractor got sued by this one customer because they were a limited accessibility customer and the website was not accessible to them.
Yeah, Beyonce as well. And yeah, that's
Yeah.
a very common lawsuit.
Yeah, yeah.
We have another one here for Mark about the participants. Does that mean the age range of participants was fairly small? Because you mentioned they were students.
The age range.
Yeah, if it was a small range.
Yeah, so most of them were from a very selected age range. We did get like a few people from out of that student bracket. So it was not all university students, but mostly university students in the engineering and the computer science departments. Yes.
Yeah, just praising you and your brilliant presentation.
Let's come back to the room.
Yeah. I was just wondering, so this is all on desktop. Is there any studies about mobile, and have you thought about how this could be adapted for a mobile interface?
Yeah, of course. So
Yeah, after that, because the
Yeah.
screens are smaller, so I wonder the effects about, yeah, if you're trying to look at something and obviously the text is much smaller.
is much smaller, yeah. So it's more challenging. So interestingly, so just for the people who are online, the question is about this research was primarily looking at desktop usage and what are the implications of this for mobile or small screen devices. So Samsung had come out with a phone which would scroll automatically as you reached the button, right? So they already had like what I would call eye tracking, not gaze tracking. So eye tracking means that they're able to detect where your eyes are, and they were able to respond to that. For example, if you closed your eyes, the screen would go blank. I don't know if you guys remember that. I don't remember the exact model. I think it was like 5 years ago, 5-6 years ago. So Samsung had a phone which responded to your eyes. So if you just
says smart, it's called Smart Stay. He was in Samsung when this came out.
Yeah, there you go. Confirmation. Awesome. So Samsung came out with that phone, but then I think they stopped using it because the cameras that you have in the phones are not high definition enough that they can get a close-up of your eyes and then reliably distinguish where you're looking. So that's the trouble you're dealing with. The eye trackers I used, they were all infrared-based eye trackers. They would shine an infrared light and then look at the reflection. So the eye tracker is a combination of an infrared camera and infrared light pointing at your eyes. And because infrared is not visible to us, we don't see it. Yeah, that's how these eye trackers work. And those cameras are not available on mobile, on small devices at the moment, screens, but that is changing. So facial recognition was not possible on mobile phones just a few years ago. And now it's becoming a standard. So it's becoming so reliable that it is being used as the primary unlocking mechanism on phones. So things are changing. Amazon came out with a phone which had 5 cameras, I believe, on the front. It's called the Fire phone. Maybe somebody online can confirm that. Quickly Google that and confirm it. So Amazon came out with a phone with 5 cameras in the front, and that was an indication that they could potentially, do something fancy. But I think it was a test product for them and didn't get them the results that they were looking for. They shelved it and went back to Kindle and other devices. So a lot has been sort of happening in that space, but nothing that is reliable enough that we would see consumer devices, small screens using it at the moment for multiple reasons. Yeah.
Would it be possible to sort of tie it in with facial recognition and use face gestures, links, and that kind of thing to trigger interactions?
Yeah, so that I would consider that as 2 separate questions. One is about facial recognition, because facial recognition is used as an identification. and the other part is the gestures, and the gestures are used as interactions. So I'll focus on that interaction side. So that is maybe the opportunity that iGaze interaction provides, using iGaze not as a standalone interaction mechanism, but in combination with other interactions. And that is probably something that needs to be looked into more, because if you see how we use eyes are sensory organs for humans, which means it is an input device for us. With iGaze interaction, we're using it as an output device. So it's not the ideal way to work. So there is some work that is already done in how you can use physical buttons in combination with iGaze, very promising results. The combination of using gestures with iGaze is something Microsoft has been working on for a long while, I think almost 5 years now. So the Microsoft research lab in the UK has been working with iGaze interaction and gestures combined together. I don't know why they're not doing more in terms of for the consumers, but they have been publishing a lot of research in that space. So that is something that I am very excited about, that the combination of iGaze interaction with other modes is very promising.
What about electromagnetic?
The brain computer interfaces, yeah. So again, so the same thing. So the things that we can get from brain computer interaction, the EEG sensors that we can just wear on our heads can give you interesting information, and if you combine that with the gaze, you can combine it for useful purposes.
So it's working.
Sorry?
There have been research and
there have been a lot of research in those areas. For example, so I mentioned in my thesis, one thing that I found really interesting was flying drones, which you're not just controlling with your hands, but also with your eyes. So the control of the drone is a combination of the joysticks and your eyes. So you look in the direction where you want the drone to go, and then you push the throttle, and then the drone just moves in that direction. And because you're getting a video feed from the drone, it's interactive. So wherever you're looking on that video screen, the drone knows where you're looking and going there. So these are interesting things that can be done. I've seen a little bit of work that was done by the US Air Force, I believe, but I'm not 100% sure. So the pilots have been using iGaze interaction for a long while, although it's not published and it's not available to be used by other people. But again, the idea is to use it in combination with other things.
So yeah, sorry, I was hijacking your question, but basically that was, if you consider the gaze as a pointer and then another action for the confirmation, I know that the brain signal is really hard to interpret and to have a clear signal is...
But did you see what Elon Musk is doing with the brain interface?
But I'm thinking just a click, like a yes-no signal might be easier to interpret. And I was actually wondering, so what is this research?
So with the brain-computer interfaces, anything that is non-invasive can easily give you like four different directions. Okay, so you can just wear a cap and get 4 commands out of it easily. Anything more than that, you need to be invasive a little bit. You need to drill into your brain, and then you can get a lot more. Then
so
you can
get a lot more. Have 4 different.
Think of it as 4 arrow keys. Yeah, 4 commands. So you can reliably get 4 commands by just using a commercially available. I think like you can buy it off the internet for $400. So just a small device that you wear on your head, 400, 500 New Zealand dollars, and you can control a small thing to go up, down, left, right on the screen by just thinking about it. Yeah. But the work that I don't remember the name of the company that Elon Musk is now funding, which is doing those micro detectors which go deeper into your scalp, and it could potentially be a game changer. Yeah.
Glasses, they get in the way of this process. I automatically took my glasses off when I did the test because I assumed that eye tracking and everything.
So think of it this way. The iGaze tracker works on shining infrared light, and then trying to detect the reflection of it on your eye, on the outside surface of your eye. If your glasses are getting in the way, then it would have trouble. If they're not, some glasses just work fine. So for example, I wear glasses, and I've used the eye tracker with the glasses, with contact lenses, and it has worked for me. But my supervisor was not able to use it with his contact lenses. So it's a combination of the eyes and the glasses and all of those things. Yeah.
And the other thing is, with something like Google Glass, they actually give a better result.
Absolutely, absolutely. So VR goggles, I think there's one available here in the research lab here. I noticed a box which said virtual reality glasses with Actigaze interaction. Yeah, because they're present so close by, you definitely get better resolution and more accurate results from them. Google actually filed a patent for having eye gaze tracking in Google Glasses before they shelved the product. From what I remember, it was challenged by the people who fight for consumer privacy. So they sort of challenged that in court, that patent in court, and was an interesting discussion that they had there. The pro-privacy group, they made the argument that this is private information where the user is looking, and it needs to be respected because Google planned on using the view of the Google Glass and then mapping the user's gaze on the view to be able to sell billboards the way they sell ads online. Does that make sense? Yeah, so they can now tell you which part of the street and which billboards get the eyeballs of which demographics at what time of the day, and start using that as another advertising stream for the advertisers. So that's how their patent was worded. The way the application was worded was basically to make that happen, and the patent was going to protect that as Google's intellectual property. So it was only Google who could do that. Nobody else could then do it. That's a long answer to your short question.
That's interesting.
Yeah.
Okay.
Just wondering, thinking about getting this technology into my MacBook or my iPad, is it just an infrared camera that you need in those devices?
So I believe what you have used was a standard camera, right?
Just
a regular webcam. Yeah. So
camera.
So even a regular webcam can do basic eye tracking now. So you don't need to have an infrared camera, is what I'm trying to say. And there are a few open source eye tracking libraries also available. So anybody is free to just download them and start using them with their standard webcams. And standard webcam is also now good enough that you can have basic eye tracking working.
What about more than basic eye tracking, like the kind of stuff that you've been doing?
Yeah, for that you would then, so the important part is to then basically have a very high definition view of your eye. So I've seen some open source libraries which use a very expensive camera zoomed in directly on to your eye. And they have been able to achieve very accurate eye tracking results. Yeah, but it's very cumbersome and still very expensive. You need a really good video camera connected to your computer, which has no lag, and all of those things come into play then.
But if Apple were going to build this into a device, then you'd think they'd probably put like a high definition camera with a zoom kind of thing in there, or infrared, or what would be the technology? Or are there a bunch of ways they could go about it?
I think there's so many ways of doing that. So there was an interesting product that was showcased by, I think it was Lenovo. So Lenovo showcased a laptop that came with an eye tracker built in, the proper infrared based eye tracker built in. They showcased that in 2012 maybe. It was made in collaboration with Tobii, the same company whose eye trackers I used in my research. So Tobii and Lenovo developed this laptop which came with eye tracker built in. But for some reason they shelved that product. It was only showcased in the consumer show, but never launched. So my feeling is that it will be launched, but maybe they're you know how things have to make commercial sense and have to be at a price point which consumers will buy at. So maybe they're just trying to figure those things out. I don't know how long it will take, but it seems that it will be part of standard devices one day. Yeah. Yeah.
That's a quick question. You said at the beginning that you made a game out of like prototype stuff. I was just wondering, like, now that you have that sort of understanding of sort of like gaze times and that kind of thing, like, have you thought about like the use case in sort of like entertainment kind of?
Of course,
uses?
a lot. Yes.
Cool.
I've thought a lot about it. I haven't, unfortunately, been able to do much about it at the moment, but it is something that I see myself getting back into doing. Yeah. Yeah.
Talking of that game, actually, didn't you have a lot of crashes, unexpected move of the?
Yeah, it was a very so it was still not as good as using the keyboard for controlling your spaceship for multiple reasons. One of them being that what you're now doing, if you're controlling your spaceship with your gaze, and the feedback of your control, you're also getting it by your gaze. So what tends to happen in those cases, if there is, let's say, a slight left bias in the gaze, then when you are looking at your spaceship, the gaze reported is slightly on the left, which makes your spaceship go to the left. But now your gaze also follows the spaceship, and then you eventually sort of fading left always. So that's the trouble with using eyes as both for control and feedback. So it was not as good as using the keys, but it was just an interesting experience.
Not so much like actually trying to control the spaceship, but then kind of stop looking at
exactly, yeah, because when the fireballs are coming in, it is your eyes which are used to look at the fireballs to check which one is the nearest one and which one is heading to mine. So that's basically crashing into them then, right? So it was, yeah. So it was a stupid thing to do, but fun. But fun.
Maybe the goal of the game should be
the more points you have, yeah. So I think what we'll do is we've got the actual eye tracker outside. We can continue talking about stuff and discussing while we also try to use it, and some of you can also try it out and try to click on hyperlinks by just looking.
Yeah, I just have one message.
Cool.
From our sponsor for Zoom. Thank you, Moiz, for the amazing talk. Thank you for coming. Thanks to NEC for NEC, is that how we say? NEC, yeah, not NEC. For the venue, and Internet New Zealand for providing the Zoom account. And you would like to share any message?
No, thank you very much again for organizing, and thank you everybody who attended, especially the people online. Thank you so much for joining, and feel free to drop me a message or email, or find me on LinkedIn, share your thoughts, ideas. Always keen to talk about this stuff.
Where can people find your thesis?
So I can send them a copy, I think.
Cool.
Yeah.
And we'll share you the chat transcript as well.
Awesome. Yeah. I think because the official thesis is available via University of Auckland's library access. So if you have access to University of Auckland's library, then you can get a copy of the thesis. But if not, don't worry, just tell me and I can send you a copy. Cool. So goodbye to the people who are online.
We're going to try something.
We can show them how we are going to be using it.
We're
awesome.
going to try it.
We try that. Okay.
Your demo set up already, right?
Yeah. So
okay. Cool.
I feel like I'm on a TV crew.
Yeah, you can pretend to be a virtual person. Maybe we'll put it here.
Yeah. Yep.
There you go. How does it feel?
Good, actually. This is.
Does the color of your eyes matter?
as
can
long
put
as
this
you
here if you
can
want.
get a reflection.
Can we move this up a little bit? so we
According
can
to
see
the
person's
manufacturer of the
face?
device, about 90% of the population should be fine. But personally, I've seen about 70% is fine. You know how some people have eyes which wouldn't open too much.
Yeah.
So they have trouble because the eye tracker is not able to get a good reflection.
So it's about the reflection, not about the shape or the color.
Yeah, so this eye tracker has on the side, it has infrared illuminators.
Yeah.
And just next to both illuminators, it's got So what this is trying to do is look at it tries to take pictures of the eyes using a computer processing. It figures out the angle of the photo relative to the reflection of the image. And that's how it figures out where the photo is going to. So this becomes a infrared light. That's how it figures out where to on a 0 degree angle. Working with your glasses?
Yeah, yeah.
So this is the Chromie store. So this is something that the university can develop after